Hi, in this video we are going to learn about solvers. Solver is not readily available in Excel, so therefore you have to download it from the Excel add-in. Solvers are very powerful, especially it can be used for solving optimization problems, linear as well as non-linear equations too. So in this video we are going to learn about how to use solvers to address such issues. If you want to follow along with me, please do download the data which is given below in the description link, and let's get started.
The topic for today is Solver. Solver is readily not available in the Excel tabs. You have to actually go into the Excel add-in and add it. So as you can see, I've selected data, and inside that there is a Solver Analyze tab. But how do you add it? So in your PC, it may not be available. So how do you add it? I'll quickly show it to you. You go into File. You go into Options. There you'll have add-ins, below which you'll have Excel add-ins. You just click on Go, simple as that, and then you'll have 4 options. You'll select the Solver add-in and do OK. Once you do that OK, Solver will automatically come here besides Outline in the Data tab. Okay, now let's look at what Solver is. Solver is a better version of what if analysis, where you can derive answers through a set of things. So let's select Solver. So this is the box that Solver comes up with once you open it. So I'll quickly go through the box. Set objectives. The first column, set objective, is the objective of the cell that you want to derive, the final value what you want to derive. To maximum of your objective, minimum of your objective, or value of what your final value you want, you can put it over here. The third part is by changing variable cells, is basically by what cells you want to change so that you get the value of in the particular cell. Below that are constraints. If there are additional constraints other than the above ones, you can obviously add it over here. And the most down part, which is the lowest part, is linear, simplex, and evolutionary solutions. So what is non-linear? Non-linear is used for smooth functions, non-linear. Simplex is used for linear smooth functions, and evolutionary is used for non-smooth functions. So we will be using non-linear smooth function over here. So let's look at the table what you've got. On the left side is a small production table from where you see hours, manpower, price, and the total cost. So what is the total cost? Total cost is just a derivation of hours into manpower into price. Followed by quantity. What is quantity? Quantity again is just a derivation of hours into manpower. So here I want to see what the total cost would be if I want to produce a particular quantity of goods. So here it is 500, it is 63 and 32, followed by a price of 100. So I want to see if I want to produce say 800 quantity, what the total cost and the hours and the manpower would be. Going into Solver. So set objective. So this is my set objective. This is my cell to the value of 800. I want 800 units specifically by changing what cells? Hours and manpower, because price is a constant value. So I change hours and manpower to get a quantity of 800. I click on solve, and automatically the solver gives me a solution, which is I need 80 hours and 40 manpower with a total cost of around 3,20,000 to create 800 quantity. That's what Solver does very effectively and simply. So things to remember while you're doing Solver. Your objective or your last cell should always have a formula. Like here in the quantity, I have a formula which is B4 by 4, meaning hours divided by 4 into manpower, which is basically for every half day, one quantity is created. That is the simple logic of the formula over here. And the cell which you're changing should not have a formula. So these are the two very simple rules that you must follow. So you go into Solver, and you again, if you want to change, say you want to do 1,000, value of 1,000, and you do solve, and the box comes up. where you want to keep the solver solution, restore original values, simple box which comes up. You do a OK, you keep the new values, which is 1000, which is 89 into 45 manpower will give you 1000 quantity with a total cost of 4 lakh rupees around. So moving to the next part now. So this is a bit complicated, where case 2, which specifically looks at is the constraint part of it. Okay, so again I'll open the solver. So now what I want is, I want to add the constraints as well. Before that, I'll explain you what this table is about. This table is simply a mobile company table where they have 3 models, A1, A2, A3, and these are the materials needed to create that mobile chip. So A1 requires 1 chip, 1 glass, 1 camera, 1 battery. A2 requires 4 chips, 2 glasses, 3 camera, and 1 battery. Similarly, A3 also requires accordingly. This is the opening inventory. This is the inventory used currently, and this is the closing inventory. Followed by the above part is the profits generated by creating one model. One model of A1 gives you a profit of 1500, A2 gives around 5000, and A3 gives around 3000. Okay, so these are the values. Followed by below profits. Profits are basically quantity to profit and the total profit. So what I want to do is, now with the set things that we have, I want to analyze what the total profits can be maximized from this particular table. Now let's add the constraints and the values which are determined to get the final objective of total profits. Now going into solver. Now what you want is to keep the value at maximum. Set objective, which is total profit, is your final destination that you want. By changing variable cells, which is the what you want to change, which is again the quantity, that is what you want to change. Accordingly, the profits will also change. So these are the 2 simple parts we learned earlier also. Now we are going to add a constraint to it. So I'll click on add and add a constraint. So what I want is profits should always be greater than equal to 0, cannot go negative. Another constraint that I'll add is the inventory also has to be always greater than equal to 0, which it cannot go to negative, otherwise the solution would be wrong. These are the constraints that I've added. Selected non-linear, and I will now solve it. So before solving it, so this is already a solved material. So before solving it, I will just change the profitability for this example. Okay, now I will keep it at say 1800, this at 1500, and now let's see how it changes. This at 3300. Now let's see how it changes, or how the profitability changes. So data, solver, all things are set. Your final objective is set, total profit. By changing variable cells of quantity, that is set. You have put 2 constraints of profit and inventory. Now you go and solve it. As you can see, this has provided a solution. What it says is, at the current profitability, you need to produce 110 quantity of A1, 10 of A2, and 0 of A3, because it doesn't match the profitability. And your final profitability would be around 253,000. So that's when you keep the solution. Now, what you want is, if you want to change the profitability, you say that I want to produce some quantities of A3 as well. I'll try to increase the profitability by reducing the cost somewhere. If I put a profitability of say 3,800 and this 800, maybe this is at 1500. Now let's see how it changes. Now you just click on solve because everything's set. Okay, what it now says is just produce 70 quantity of A3. So obviously there are a lot of permutations and combinations that you have to do to get your desired answer. But this is one of the ways you can get the answer correctly. Now let's put one more combination. Click on solver and OK. Now this gives again a solution of around this. And if I change this to 1800, again a new solution will come, which will straight away say that produce all A1 quantity, because that is the most profitability that a company can achieve by producing just the A1 model. So this was about solver. solver is used to derive lot of analysis with regards to your productivity, your sales, your profitability, employee salaries, etc. So obviously, two facts to remember is simply always have a formula in your objective cell, and the second part, that on the changing value cells, do not keep any formula. That should change automatically through numerical values. And obviously add constraints wherever you feel that if your formula or your entire model will go wrong, please add constraints so that it's easier for you to get the answer, and that to the correct answer.
I hope you found this video to be useful. Please do like, comment, and share this with others too. We do come up with lots of finance and Excel videos almost on a daily basis. And if you haven't subscribed to our channel yet, please do subscribe so that you get the notification as soon as we release a new one. So thank you so much for watching. Goodbye.